Today we're going to be talking about, you might have guessed by this lovely title slide, technical debt is a systemic problem and not a personal failing. So at least 95% of you should be breathing a sigh of relief.
Just curiosity, how many of you are developers here?
See, I told you, 95%.
And testers?
It's all your fault.
And managers? Okay, great.
Oh, good. Good. We want to talk to managers.
And did I miss anybody?
All right, so for those folks who may not know us, he is Declan Whelan. I'm Chris Chapman. Slides have us kind of backwards. We should be standing on the other side. So I'm an Agile coach, lean Agile coach. I own my own company. It's called Derailleur Consulting. And I consult to, or I coach teams usually in mid to large size organizations who are trying to get started on their first journeys into implementing Agile practices, techniques. I'm also the founder of a meetup group here in Toronto that meets once a month that's called Systems Thinking TO. And through this meetup group, this is part of what I'm here to talk about with Declan. It's a little bit of country, a little bit of rock and roll. So Declan's providing the rock and roll, I'm providing the country. Declan's much more gifted and much more able to speak to the technical stuff. I'm here to help support him with some of the system stuff. So that's how you can find me on Twitter. You'll find me opining about a lot of things systems. You can find out about our meetup. If you go to meetup.com/systemsthinkingto, you can find out when the next one is. And I strongly encourage, if you've never come to one, please do. It's a really fantastic socializing aspect to it. And we have a fantastic guest speaker who is coming. How many people here are familiar with W. Edwards Deming? Anybody? Yeah. So we have got Dr. Bill Bellows is coming from the Deming Institute down in the States. He's going to be delivering a talk. So that's on November 28th. So you can find out more details there. Declan.
Yeah, I'm really glad to have Chris here because I spent the last, say, few years really digging into technical debt and trying to understand how I could help organizations deal with technical debt in a stronger way. And I'm an Agile coach, so I have the wonderful opportunity to go to lots of organizations and see how they work, look at their codes, and see the results of that. And I'm usually confronted with, we have a huge problem with technical debt. And it seems to be a systemic problem, and hence probably a systems approach to it might help, and that's why
That's why I'm here.
And so help me out. I'd be curious just to know, like, if you were to rate your organization in terms of the impact of technical debt and like what your let me frame it in a positive way, technical health. So if you feel like your organization is technically healthy, you can release near continually, new features are easy to add, you're rarely slowed down by the quality of the code or the infrastructure in which you use to build your code. That would be a 5, and 1 would be, oh my gosh, it's just a struggle to get anything out. So just hold up your hand and see where you are. Between 1 and 5, so lots of 3s, a couple of 1s, 2s.
Got some high performers.
Got some 4s, awesome. Any 5s?
I got some fists over here. Oh, wait, 2. I thought it was a fist.
Okay. So maybe you could advance this.
Yeah.
So we're going to sort of dig in a little bit to what is technical debt, just to make sure. We're not going to do a deep dive on it at all, but just a working definition for today. And then we're going to sort of spin over to okay, well, how would you look at what would be a systems thinking view of that? Because it's not just the developers that are writing. It's not the person at the keyboard that's maybe the root cause of the technical debt issues. At least that's the premise for today. It's a wider systemic issue. And then we want to connect the dots by saying, okay, here's some systems thinking, here's technical debt. Let's put those together and see if we can actually get a systems view of why technical debt might be a problem, and probably more importantly, how can you change that system to get to a more technically healthy state? And I've been using the word technical health to describe that. So technical health being the health of our system. And we'll spend some time sort of looking then at some...
I'm sorry, we can't hear you in the camera, there's only one working mic. you give him your mic just to?
Sure.
Sorry to interrupt.
This will be
Do we
edited
need to
out later.
rotate back?
We're trying to get somebody that may have another mic to bring in. Otherwise, if you have it, just to hand.
Okay, we can just do that.
Okay, that'd be great. Thank you.
Do I need to repeat anything?
No,
No, it'd be too hard.
Don't worry. Blah, 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 systems thinking, it's all great.
Yeah. And we'll be introducing one of the tools from systems thinking primarily, which is called causal loop diagrams, to explore the cause and effect of different aspects of our system and how technical debt weaves its way through the way that we build software every day. And then we'll wrap up.
Yeah.
And the quick thing is, if you have any questions along the way, because we're going to be sort of looking at different aspects, so we'd encourage you just to put up your hand and ask a question, as it comes into your head, rather than storing it up to the end, because it'll make more sense in context.
Yep. Alright, so. Okay. So, I have a question. Let me get this right here. This question comes from W. Edwards Deming. For those who are familiar, he used to start his 4-day management seminars with this question. If we were to have a national referendum, the ballot question is as follows. Are you in favor of quality? Yes, no. So let me just run this experiment here. Asking this question, are you in favor of quality?
Yes.
All right, that's awesome. Okay, so the next follow-up question is, by what means? So if you're in favor of quality, how do we get that inside of an organization? Anything? Anybody?
We test more.
So we do things. So we do things like testing more. When do we test?
At the end of the process.
Yeah, that's the best place.
Quality should be built in.
Yeah, that's an interesting perspective. Yeah.
You should plan for the quality. Think of what's going on before you start, rather than coming at it afterwards.
Yeah. Very smart. From the testers in the room. Not to put you guys on the spot, how do you perceive quality? How is it achieved in an organization?
Depends on what you mean as well. It could be whatever the customer wants, whatever's good enough for them as well.
Less defects.
Fewer defects, right? Yep.
I'd say determine your risks as a first starting point.
Yeah.
To be able to figure out what quality means to you.
So we're doing things, right? Okay.
Quality also means what it means to the customer.
Yeah.
And the customer focus.
Yeah. You, sir.
Management providing the funding to bring systems up.
Very good. Right. So Deming has a description here. The reason he's so fascinating is he was tackling the problem of how quality exists inside of organizations 40, 50 years ago. For those who don't know him, he was responsible for helping the Japanese achieve the standards of quality that eventually overtook the North Americans with respect to many of the manufactured goods they made, most notably cars. So this sets the stage for where our story begins. This might feel perhaps a little too real. It begins with a team that, with the best of intentions, wrote some code and tried to get it into a customer's hands. And the customer began to notice that there were problems. And then the team tried to address those problems, but they didn't have enough time to address them. And they found that instead of fixing problems, they were beginning to surface even more problems. And very soon, a conflagration took over. This is what we call, this is your first introduction to a causal loop diagram. It is of a type that we call the vicious cycle. And it's one that is not easy to break, especially if we don't have the knowledge about how to break that cycle. So let's talk a little about technical debt.
So Lord Cunningham invented the term. I was wondering when the year was, but I'm thinking it's in the 90s. I could be wrong. Does anybody know? I think it's in the 90s. But he described it like if you write code for the first time and you don't write, the words he used were not quite right. If you don't do it quite right, then you put a little bit of debt in, and then you're going to have to spend time later on addressing the not so quite right code, which he now calls unfactored code. And the time that we spend doing that, rather than building the valuable stuff for our customers, is called technical debt. And it is interesting to note that at the time he was working for, I think it was the original C2 project at Chrysler, and he was working on a financial system, and his boss was a finance person. So the metaphor sort of interestingly had a financial angle to it, and that's sort of where the term comes from. And for today, I would like to sort of have a slightly different definition because it will open us up a little for systems thinking, which is artifacts we build that impede delivery of future value. Something we do today that's going to slow us down delivering value tomorrow. And you can see like the big ball of mud as the team's just trying to push this big ball of mud, and they're sort of hampered by the system that they're in. And by the way, that reference to the big ball of mud is a fascinating read from 1999 around big balls of mud of code and a few other patterns. It's a really great read. And so this is the definition that we're going to be using for today.
Yep. So there's an important implication when we start thinking about, when we start thinking in systems about quality and about where it comes from and how it's made possible. And when I talk to senior leaders, I often try to start my conversation by jarring their frame a little, making them aware of some of the things that are systemic as opposed to just the fault of not typing fast enough, as my friend Adam Garrett might say. And this is a very big one. The problems that we see inside of an organization, technical debt, technical health or otherwise, things going wrong or even right, are attributable more to the processes, the methodologies that you have in place than they are the people. And it may feel that this is a little bit challenging. In fact, how many people are kind of a little uncomfortable about what I've got on this slide right now? Is anybody uncomfortable, or does it feel really, am I talking through my hat? No, it feels about right. So Deming made this observation in the 1970s when he was talking with the Japanese and into the 1980s, trying to help them understand things. And I've noticed a parallel in the coaching that I've done with teams, is that technical debt focuses on often sharpening the sword, if you will, at the team layer, but often not thinking about, well, the sharpest sword in the worst process is not going to yield an overall improvement. And some of this is what Declan, when he approached me about doing this talk, he said, this is what it feels like. This is a synthesis or an accumulation of what I've been noticing as well. So to get into this, we need not only a working definition for technical debt, we need one for what is a system. So I'm going to start you off with my favorite guy, Deming, again. He talks about components and their interdependency. And they've got to work together to accomplish a purpose for the system. Second most challenging question I ask leaders after what is quality or how do they define quality is this one right here. What is the aim or purpose of your system? It's a very tough thing because we can be inside of an organization which ostensibly is trying to crank out application code or is trying to crank out microservices. But if it's not towards an ultimate aim or objective that meets our customer's definition of quality and helping them do things, this is good effort after bad. This is how we get into situations where we accumulate a lot of practices and processes inside of an organization that lead to the big ball of mud that Declan was talking about. This isn't a system. Inside your organization, you may have an org chart. You probably do. I've worked for several. In fact, I worked for Microsoft for a couple of years, and it was an onboarding game where you would spelunk through the organizational chart to see how many degrees of separation were between you and Steve Baldwin. Take it for what it's worth. But this is not a system. This is a reporting structure. It tells us very statically how a complex system, like a business, was deconstructed into neat little boxes. It projects certainty. But systems don't work that way, right? And you've probably observed this inside of your own organizations. You will find different divisions and departments. Well, let's just call one technology and let's call the other one the business. And they're continually reaching around each other to get something done. Communication paths go in all sorts of weird and wonderful directions to make something happen that defy the org chart. So, how do we think in systems? We know what a system is, but we know what a system isn't. What is systems thinking concerned about? And yes, it's thinking about systems, but it's a little bit deeper than that, of course. It's actually looking at the causations of things, not as the result of some isolated, localized problem. It's trying to see what is the impact of the relationships that exist and how our system is constructed today that bear consequence for how we're trying to deliver something of value to our customer in the future. So we're very interested in understanding the behavior of the containing whole. I often tell my leadership coachees, your first stop when trying to figure out why something is going wrong in the organization is not to focus on blaming the individual or the team. It's to ask yourself a question. How have I constructed the containing system within which that team is working that led to this outcome? And lead with curiosity from that point. Start asking questions. Be curious, be inquisitive. Now, systems, of course, when we want to get a good understanding of the rubric, they have many parts. They're interdependent. They've got a definable purpose or aim. We've got inputs, we've got outputs, just like a digestive system, just like a human being, a solar system, an automobile, everything. Each part in the system, this is particularly important, is built for a particular purpose. And the purpose is interdependency. It works in relationship, in concert with another part of the system to do something. So if we look at this bike, this is not just a bike you would take for a trip down the K. Gardner Beltline. This is a time trial bike. It's built for a specific purpose, to take a specific type of athlete and translate his human muscle power into lateral speed very, very quickly and over a sustained period. So there's two parts to this system. There's the bicycle itself, the physical hardware, but the rider too, working in concert. Same way, inside of our organizations, we're very concerned about how human beings work inside of it. This has a knock-on consequence. If we try to take systems apart, we can't understand them just by looking at the parts by themselves. There's a very important reason why. You'll probably figure this out. This is a picture of a Porsche Boxster engine. It's got about 280 parts. If I was to ask you, how does the Porsche Boxster engine work? I've laid out all the parts here. This is the org chart for the engine. How does the engine work? Would this engine work if I dropped it in a Kia Sorento? Probably not, right? It's built for purpose. So this engine is designed to marry into a vehicle very specifically. And what's necessary to understand is what is the relationship between the parts that yields to the whole. If I try to understand and analyze different fan belts and cylinders and exhausts and manifolds, I come no closer to understanding the purpose of that system and how it works. But that's exactly how we treat organizations. And this has a knock-on consequence for technical debt. Naturally stands to reason. We can't improve a system by just improving a part of it. So a lot of our efforts when we think about trying to improve the technical health or technical capabilities of an organization, much as I've said just earlier, you can't focus just on a single team. There are things that are going to keep them from being able to achieve that. Conversations I've had with some of my leadership coachees have gone something like, I am quite certain that if your leadership, so let's go up to the C-suite, were as aware of the challenges you're facing with respect to getting delivery of value to customers on shorter timescales, more cost effectively, that everything in this organization would turn on a dime to focus on solving that particular systemic problem. Instead, we're often focused on trying to fix parts of the organization in isolation. And that's yielding what we call a suboptimal result, not a systemic result. So I'm about to set this up right now for Declan. You ready, Declan?
Yeah.
Okay, cool. Let me introduce this diagram. I'll hand this over to you. So we're going to leave you with what we call in systems thinking a core competency about how do we perceive systems so that we can see the cause and effect relationships of what happened inside them. And this one, Declan, was fantastic. It was fantastic. He was able to find this. This relates the systemic problem of childhood obesity. All of the contributing factors in cause and effect loops. So everywhere where you see an arrow going from a bubble that's got words in it to another one, that's a cause and effect relationship. And you can see some lead to others that lead to others that lead to others. When you're trying to understand a system, the org chart doesn't help you understand why things are happening. Something like the causal loop diagram can. And this is something that you can begin to take forward into your organizations to understand how they work. Take it away, Declan.
One thing I really liked about that slide is, like, you probably can't read it, but somewhere near where the blue meets the red in the middle is something like kids should stop eating junk food or kids eat too much junk food. So you would sort of think at a simplistic view, if we wanted to solve childhood obesity, all we have to do is stop kids from eating junk food. Yeah, how well is that going to work when you look at all of the other systemic forces that are sort of impinging upon this child, whether it's physical activity, peer pressure, how their parents model, the TV that they see. There's so many influencing factors that are going to likely lead them away. And I sort of think that's how some organizations feel about technical debt. It's you, those developers, you wrote the bugs, you put in that crappy code, you were at the keyboard, but it's sort of overly simplistic to blame the developers. And since I'm a developer, I can sort of take that personally.
Part of the problem.
And you know, and it's and as Chris pointed out, you know, the people thinking about, oh, I'm just hiring crappy developers, or those offshore folks are, you know, they're crappy. That's only 3% of the problem. This sort of shows us that there's a bigger problem at play. And so I wanted to introduce, first of all, the idea of technical health. And I've been sort of studying technical health for a few years, and technical debt, and I've decided to start to experiment with calling it technical health. And it started simply from this premise that people are more motivated to increase positive things than they are to decrease negative things. So I sort of like that part about it, right? It's not like it's a bad thing, it's like we should try to improve something that's positive. And it turns out that there's evidence from the field of psychology that shows that if you are clinically depressed and you focus on trying to focus on the symptoms that people have and try to get them out of the depression, you can get people to like a, yeah, I'm okay state. But if you actually really focus on what makes them happy, you actually focus on the positive, you can actually get them to a much better outcome. People actually being happy rather than just meh. So that was sort of where I started with technical health. And so that aspect of it's a positive thing, and actually there's proof that thinking through positive terms can lead to better outcomes, with the hope that if people talk about technical health, it'll lead to better outcomes, and let's just decrease that bad stuff. No, let's talk about how we can help our organizations deliver better value. And the other thing that I thought was also a reason why I like the metaphor is, you know, I have my mother-in-law is 93 years old. She's really losing mobility, and for her, being healthy is that she can successfully navigate a day without somebody having to come and help her. Like that's healthy for her. So the concept of health is sort of now can be sort of tuned to the context at play. The organization, I think you can be healthy. My healthy can be different than your healthy. And what's valuable in our context? And so I've drawn this sort of simple causal loop diagram here, which I think is sort of the core of what we're talking about here, where we have technical debt, and that, by the way, in this slide, most of the slides here, I think all of them unless we make a mistake, the red is generally something that you'd rather not have, and the green is something that you would rather have. And then the arrows are showing the causal connections. And the plus sign is saying that that's increasing, has an increase, that the cause and effect is an increasing one. So for example, if technical debt increases, then that's going to increase future burden, rework down the road, bugs, things like that. And then as we have that extra work, unplanned work down the road, that's going to decrease our productivity measured in terms of value to customers, because we're spending more time with this, fixing the stuff that we did before. As our productivity drops, that's likely to increase our pressure to deliver. And then that pressure to deliver is probably going to push us into making more short-term decisions about the code and leading to further technical debt. I sort of see this loop or something like this at the core of most organizations I've worked with, right? This is a vicious cycle. There's nothing in here that, if you don't do anything, this technical debt is going to eventually probably bring you to a near standstill. I've worked with organizations that their developers will say they spend 80% of their time in the future burden and only 20% of their time building future value. And when they are building future value, that code is actually hard to work with because there's technical debt. So I actually worked with one company that when I did the math, they were actually working at about 5% of their potential capacity. And I just recently was working with a company where they recognized that it was somewhere, the team felt that they were somewhere between 30 and 70% depending on the person. So this is like real and has a huge impact. And so I like to call this technical health which is what is the capacity of our system to deliver future value. So it's not a different term than technical health, it's technical debt. It's casting technical debt in a systems view is the difference. It's not a replacement term.
And to be certain, this is very simplified. So we've tried to make this, let's start simple. Let's start with the core of what we're seeing in the causal relationships to start. Of course, it's going to have some complexity that's going to come.
So most of the rest of the presentation is going to be digging into sort of zooming in on some aspects of what this system might look like. But before I go on, is there any questions sort of on how to read that causal loop diagram on the right? Make sense? Okay, so we're going to dig into a few. And they'll mostly look like this, where I'll have a title, and then we'll just explore how they might work and how they might be impacting your systems. And these are not meant to be sort of like the reality. These are just meant as ways that Chris and I shared. Here's some common patterns that we've seen, and the craftsmanship here is just one lens to look at the system through a causal loop diagram specifically around technical debt. So we could read this by, there's lots of good stuff going on here, right? If we have a lot of strong craftsmanship, we're going to end up with cleaner code and cleaner architecture. And I'm finding that those become reinforcing too. When you have cleaner architecture, it'll help you figure out where to put the code, which will lead to better code. If you have clean code, it's better to see architectural patterns and improve that architecture. So that's a virtuous cycle. That's a good thing. We like that. And the same thing happens with joy. One of the things that I just love working with well-factored code. In fact, I actually like working with really poor code as long as I can make it better. But the joy about applying craftsmanship, autonomy, mastery, purpose, getting that mastery of craftsmanship brings me great joy, and I think it does a lot of other people that I work with. And the way to get to craftsmanship are really, I believe, is extreme programming practices clearly lay out how we need to, how we can build, how we should be, what are the practices that we should do are clearly articulated by extreme programming. And most of those come from the 50s and 60s. So extreme programming practices, but I find that they're rarely practiced.
And why would that be? He asked knowingly.
Is anybody, who here is doing extreme programming practices sort of on a regular basis? Couple, awesome, right? And I think there are, we're not going to go into it, but I think there's some systemic reasons. I train a lot of developers on extreme programming practices, and I find most of them have never even heard of them. So that, you get a computer science degree and you think people would know how to code, and they don't. Or they don't know how to code as craftsmen. Yeah. They know algorithms, they know data structures, they understand the theory of computing, but in terms of writing practical code, they just haven't been taught the skills. So I think there's a deep systemic problem with our the way that we with our educational system around training programmers. I think boot camps and things like that help, but still, it's still a very 101 level. So it's really important then to, if we're going to apply extreme programming practices, there has to be learning because it's rarely there on teams. So we have to find ways to amplify learning. So if we combine the learning with the XP practices, and I'll explain what those are in a minute, then we can get to better craftsmanship, which will then sort of be an offsetting factor in mitigating. This is called a balancing loop, where we're trying to decrease this runaway cycle by introducing some other pressure on the system. And you can see the last loop there is when there's pressure to deliver, that will sort of make it more difficult to be a craftsman because it might be hard to write the right code when you have to fix that thing like this afternoon. To do it well might take you more than this afternoon, so you might be under pressure. So that's the general flavor, and really the point here is that we need to be introducing craftsmanship into our Agile teams. And any questions on that? Does that make sense?
Sure. Is productivity and future words on every slide or in every map? Like, why do they represent it differently?
I think what I was trying to do was show that the ones that are actually filled in are actually relevant. But on all the slides, you'll see these 4 just to give you context. And if it's filled in color, in this case, technical debt and pressure, they're relevant. Like they're directly relevant to craftsmanship. Make sense? Okay. Good question. We're both Irish, so we
The link.
the intelligence. Did you have a Guinness today? Is that why you noticed that?
Okay, so let's see where do we go from here?
So here are the extreme programming practices on the right, and basically the ones inside the 2 circles are the ones that I think are relevant. And interestingly, Scrum could be loosely defined by the planning game and maybe small releases. In other words, extreme programming is a superset of Scrum. And by the way, who here is doing Scrum?
Yeah.
A lot of people.
The world's
So
most popular
what does Scrum say? What does the Scrum Guide say about technical practices? Nothing. Zero. That's left up to you, right? That's left up to, and it's sort of very smart that they did that in a way, because they weren't trying to mandate it. They were just saying, here's a good planning framework. But they didn't say how to actually write, test, architect. That's not in Scrum. So if we're doing Scrum without those things, we're actually potentially in a world of hurt. Let me give you this example. If your intent was to write big mounds of technical debt, like let's say that was your purpose, like what might be the best way to do that?
Type
Well,
faster.
Maybe we should have like rapid iteration loops so we can build that stuff quickly. And maybe we shouldn't introduce any technical practices at all so that we can just make that as messy as we can. In other words, Scrum without technical practices is an awesome way to build massive technical debt efficiently, right? So that's being nasty. I don't mean to be slamming Scrum here. I would say it's any iterative system that doesn't take care of the craftsmanship part of it. And in this talk, I don't want to go into these practices to describe them, but you probably test-driven development, pair programming, simple design. I think next door, Alistair is talking about simple design. But here are some things that you might do. And on these slides, whenever there's a square box, it represents something that you might experiment with or try in your organization. So some agile training, some coaching. Pairing mobbing is a great way to share knowledge, especially if you have a craftsman on your team that can share. Code reviews, coding katas, book clubs, lunch and learns, code retreats. Technical debt tools, for example, linting your code, checking your code inside your IDE, or perhaps something like SonarQube, which will be doing code analysis on a regular basis. But here you're really just measuring the quality of your code.
And of course, all of this has to happen in the context of a system that permits it. We've listed a lot of great things here. How many folks are doing, for example, pairing or mobbing in their organizations? Not an overwhelming number, right? Like it's kind of like 30% maybe. And ask the question, why? Oftentimes, as coaches, we hear the pushback on pairing that it's inefficient. Why would I pay for 2 developers to look at one screen?
Yeah. So the way to have a different conversation is to draw a causal loop diagram and show how technical debt, the accrual of technical debt, is having a long-term impact on the organization, and how might we break that loop by promoting craftsmanship through learning. And then you've opened up the door. You're not trying to justify pairing on a transactional basis that's half the productivity. It's more like, no, we have to do something here at a wider level. And by the way, studies show that pair programming is as productive as regular, as people coding on their own, but with significantly less defects. So you could find, if you actually wanted to do that, there is research that shows that you actually do not see a loss in productivity. Okay, so that's the craftsmanship view, and some things that you might want to try. Defects and errors. How many people have problems with sort of like errors, production errors in their systems? Maybe not some. Some? Okay. Not horrible, right? I'm working with an organization where it's almost crippling them. I have 30, I got on their email list of all the errors, and they get 30 a day. Some of which I need to ignore because they just, they're not really errors. They're reported as errors. So these errors are really, really hurtful. For one thing, A, they're caused by defects in our code, usually, or they could be infrastructure, but let's just talk about defects in the code. And then that immediately subtracts from productivity, because now you're having people firefighting instead of doing what they would really want to do. And that means that if you go up here, they're also having to have a context switch. They're going to have to switch away from what they're really doing to go fight the fire. And if they try to keep on track with what they were doing, then they might have to work overtime or weekends. So now they're going to be fatigued. And those things are going to combine to have them just trying to put in a quick fix. Just get the bug fixed. Don't worry about the quality of the code. Just fix that bug. So they'll probably hack something in. We'll call that a quick fix. And lo and behold, we've now added to our technical debt. And of course, now we have another vicious cycle here. So, you can see the green things would be the things that you might want to think about of how you would dampen that effect. We have test automation, exploratory testing, and code analysis, which we talked about in the previous slide. And trying to take the cue from Chris about it's a wider systems problem. One thing that would be really useful, and this comes also from extreme programming, is sustainable pace. Let's just, if we have a leadership mandate that we don't work overtime, that we don't work weekends, if you really encourage people to have a sustainable pace, then we will at least reduce the fatigue factor, and more likely that we'll actually have people doing quality work because they're going to be well rested and alert.
We might involve them in, the estimates and shaping the work too. Crazy.
Yeah. So that would then decrease the quick fixes, and more likely that we'll do a good fix and have a positive impact on technical debt.
Yep.
The other thing that I've noticed about errors is, you can't, I think it's useful to strive for 0 defects, but the reality is I have a client that gets 30 a day. They're not going to get to 0 defects anytime soon. So at least, optimize how quickly we can detect them, get meaningful information to people that know how to fix it, and then work on recovery, whether that's a backup system or a blue-green, or some way of rapidly recovering to at least take some pressure off this loop here.
So Declan is raising potentially it's a subtle point that he's making here, but I'm going to loop back here, being the systems thinking guy. It's that your organization right now, what you might want to try doing is constructing something called a run chart. And just look at the number of escape defects that happen either on a weekly basis or a daily basis. And what I want you to do is plot 2 lines on it. Look at the median, the mean. What you should see is that your escape defect count is probably going to oscillate around that mean. You're beginning to figure out what the heartbeat is of that system for producing defects. And then I want you to put 2 more lines. I want you to put a line underneath and a line above that mean that's 3 standard deviations. So 3 standard deviations above the mean, 3 standard deviations below. These are what we call control limits. And what they allow you to perceive is what we call the voice of the system. That's often missing here. All of your systems are calibrated to produce quality versus defect at a predictable outcome rate. So when we make changes to try and improve the system, if we're not aware of how it's working right now, we can actually make that worse if we're not perceptive enough. I've had customers where you could pretty much set your watch by when they would have a major system outage, because it would happen every 3 months. 3 to 4 months, you could be sure there was going to be a big bang. Yep?
When you say escaped defects, do you mean those are ones that your own team didn't catch before you?
Correct. Correct. You want to look for system metrics as opposed to person metrics. Something that allows you to understand how is that system performing overall. Take the lens back up, and again, this is about providing leadership with data so that they can make great decisions about how to manage the system better. A lot of the things Declan is talking about suddenly make sense. It's no longer about, yeah, you guys need to pair and maybe we got to send you on training. I don't know, the budget doesn't allow it, we've got deadlines. All of these other things are noise. When you plot something on a control chart and you look at what is the heartbeat and the voice of the system, suddenly all that noise goes away. And now you're really focused on, this is what we're truly capable of doing. How do we get better? How do we design systems inside of our organization to support that?
I really like that part you said that Declan makes sense. Could we record that? I want my wife to hear that. I don't think that's ever, those words have never come from her mouth. So craftsmanship and errors and defects are sort of really interesting. Has anyone heard of mob programming? A few people, where basically you have the whole, anybody doing it? Awesome.
Awesome.
Awesome, awesome.
Do more.
Sometimes, yeah, it's good just to try it a little bit at the start. So Woody Zuhl, the guy who invented mob programming with his team at Hunter, what they have is over doing mob programming, which is the whole team programs in front of one computer. So if you think mob programming or pair programming makes no financial sense, mob programming is like WTF. You just have one keyboard writing code at a time. They've had 3 defects in 5 years. So you can imagine the productivity boost from not having to deal with all of this crap over here, all the error detecting and the fatigue. They just don't have to worry about defects or errors or production problems, troubleshooting, going through logs, all that crap. So here's some things that you might want to try. I loved Chris's suggestion about tracking defects, which I called here measure and track failure demand, automated test, exploratory testing, static code analysis. That could be inside your IDE or as part of your build. Striving to get to continuous integration so that we're integrating the code sooner so those bugs are popping out together with the automated tests so we can find them. Feature switches. I think there was a talk earlier. Didn't we go to that on feature switches? So yeah, so basically allowing you to release code out to the production even though that capability might be not turned on yet to reduce the likelihood of having bugs crop up during Big Bang integration. And instrumenting the code. There are lots of tools out there like New Relic that will, if you do have an error, it'll help you diagnose and find performance problems and things like that. And the one at the top, which I didn't mention, is just this quality first attitude that quality equals speed. Sometimes we think we need to trade off quality. If we get it out fast, quality will, there's a balance. You have to either go faster, or you do it well. Well, we know in the short term that's probably true. In the long term, quality equals speed.
Yep.
So really getting that idea that if we want to be fast to market, if we want to be able to deliver valuable products at the market cadence, then we need to be building quality in all the way, and we need to be striving for 0 defects.
And that one thing I want to be very particularly careful about with this is don't run into your team room and slap up a poster that says this and then have HR orient you to it. Be very, 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 very careful. So Deming would he has a list of points of anti-patterns of behavior and leadership that lead to worse outcomes. And if your system, for example, is calibrated to produce at your current technical skill level, plus all of your infrastructure and investments, et cetera, if it's calibrated to produce 8 defects a week, putting a sign up on the wall that says go for 0 is a sure way to make things a whole lot worse. So when Declan lists that quality begins at the CEO level downward, that's a fundamental philosophical shift that we're going to be invested in helping our organization design better systems and practices. It's going to be technical competency first. And we've seen that happen in organizations outside of Canada where the leadership is actually, like Capital One, I think is one. I think ING is another, where they have stuck a flag in the ground as the C-suite leadership and said, enough is enough. Technical excellence is our core capability, our core competency. Everything we do in this organization is now shifting to support that because that's how we get things done. That's how we please our customers.
So we're probably going to have to go a little bit quicker, Chris.
Yeah, we're a little over. So let's race. We got 15 minutes. We can do it. It's
So
okay.
I want to just bring in the human element of psychology and talk about how if we have blame, that's going to subtract from awesomeness, which we heard from Josh Karavetsky is, we want this, we want our people to feel awesome. If we don't have that, that's going to lead to turnover, and turnover is going to have a huge productivity impact. And even if they don't, people don't turn, even if they don't leave, they might at least get burned out by having to deal with all of this pressure and not shown on here, but the defects. Again, that will have a negative influence on productivity. So a few things we can do is to really start to make it safe. Make it safe to write code. Having automated tests helps with that. Having automated builds that catch errors. Making the code clean enough that you have the courage to go change it, because you know if you make a mistake, you're immediately going to get feedback that there's a problem.
Yep.
If the bugs only show up in production, that's going to make people really cautious and very likely just to hack in code because they don't want to really fix the code. They just want to make sure that that bug doesn't happen. So the code will atrophy with layers and layers of that sort of quick fix. And of course, back to the leadership front, we need to be we need to be actively building a blameless culture where if there are problems, it's not about blame, it's how did our system fail us? How can we prevent that from happening again? What is our trend? And really moving to working on the system where 97% of the problems are with our system, not with the personal failings of people. And couple of psychological, the present bias is sort of an interesting psychological bias where as humans we're more likely to value a short term. We overvalue something that's in the short term rather than the long term thing. Something that we might get value from 3 months, we tend to undervalue it even if the math worked out the same to something that would have immediate benefit next week. So you can think about iterations and think about fixing bugs. That's going to probably, our brains are wired to overvalue that quick thing rather than the long-term benefits of having a technically healthy system. So it's something we have to, it's not like a failing, we're all wired that way. We all have that built into our brains, so we need to one thing is try to offset that by rewarding improvements in quality of the code. And to do that, we might want to measure it in retrospectives, et cetera. Yeah.
Sorry, would you say that's a benefit of moving to a DevOps versus project and handing over to ops environment?
I never thought of it that way, but that sort of makes sense to me. Could you say more about that?
Well, so if you think about it, if I'm in the DevOps, I'm going to own any future issue that I create. I might be more inclined to look at it from a better technical health perspective. And then the project team that might be handing my code over to operations.
Yes. Yeah.
Yeah.
If you own it, you run it, basically, and you're more likely to take care of it because,
It's more of a
sense.
systems approach.
Yeah. Good point. There was another hand up?
No, I think Alvaro was trying to point out that your microphone.
Oh, thank you. I was trailing. So one thing that came out of Michael Feather's book, which is Working Effectively with Legacy Code, is you can create oases of good code. So it can be daunting to look at a horrible code base, but at least you could say, let's make this part of the code better. And then get people excited about that, and then that will grow, rather than trying to make it better everywhere all at the same time. Measure technical debt reduction, and we already talked about a few things with making it safe. And let's make everyone awesome. Let's stop blaming the developers for the bugs, and realize that they're not. I don't think I've ever met a developer that wakes up every morning saying, "How can I write the worst possible code today that will cause maximum production problems?"
Depends if you're looking to escape.
So we have to go with the assumption that people are doing the best that they can, and if they're not. If they are producing poor quality code, it's not their fault. There's probably a reason for it. They don't have the skills, or they don't have the motive, or their system forces that are causing them to take shortcuts. Organizational structure. I think, my experience has been a lot of the problems will happen with, first of all, handoffs between teams, right? So minimizing handoffs between teams is a good idea. So thinking about our organizational structure in terms of our architecture and new features we're building so that we minimize the coordination that we need between teams. And Amazon is a good example of that, where they have sort of mandated that every team has to have a RESTful web service to sort of make sure that those teams are as decoupled as possible. And basically making design decisions that are reflecting their organizational structure that they want. Dedicated teams, I think having people switch from one team to the other. Oh, I'm working on 4 projects simultaneously. Is really, really challenging. It's hard for them to. That's definitely going to increase technical debt because they're just flipping around so much. Or if you have people drifting in and out of your team. I'm working with an organization right now where Joe has capacity this sprint. Let's bring him in, right? And that's not going to work out all that well because then going to be gone and not have to live with the consequences of either his good code or his bad code. This is the organizational model that a lot of people you're probably tired of seeing the Spotify model. Has anyone seen the Spotify model?
That's every conference has to have that question at least once.
But at least it shows, what I like about the Spotify model are not necessarily the details of it, but they've intentionally architected their product offering reflects the organizational structure that they want and the values that they hold as an organization. So they build guilds and tribes and chapters. And this is a good example of Conway's Law, where the architecture of your system will reflect the communication channels in your organization. So we can use that to think about what is the architecture that we'd really want, and then construct the teams that will give us the communication that will support the architecture that we want, as Amazon did. Don't anyone here an executive? But don't outsource core intellectual property, because then almost every time I see technical debt is outsourcing, it's always blaming those outsourced people, right? But that was our choice to outsource it to them, and outsourcing is hard. It rarely has worked out well in the experience that I've had. Let the team get involved with hiring and respect the mythical man month. I was working with one team where the project manager would routinely go around the team and talk directly to vendors and say, we need another developer. And then on Friday, this happened to me twice on the same team. Oh, meet Annie. Annie's the new developer. What? The team didn't even know that that there was a problem. And of course, Annie joining actually decreased productivity because she has to get trained and other people are. So it actually, the mythical man month tells us that 9 women are not going to produce a baby in 1 month. So neither will typically adding developers will typically make the problem worse.
Yeah, if you haven't, or if you're not familiar with Fred Brooks Jr.'s book, that's the one to read. That's from 1975. Yeah. Original systems thinking and technical debt, all in one book right there. Too few managers I know have read that book, and it's so fundamentally important because it explains principally the challenge we face inside of our organizations. Quick hint, it's because the tasks we have are not cleanly partitionable. And that's why we have to have high communication, and that's why when you swap people, it impacts the system. Cool. Carry on.
I think this is the final causal loop diagram of just ways that you might want to reduce technical debt. And I've identified 3. Because sometimes you do, technical debt, I hope it's sort of clear. Technical debt's not inherently bad. It's only bad if it gets to a point where it's affecting your ability to deliver on your system's purpose, which is to deliver value, typically for us. So a few things that you could do, I've seen teams do, maybe some of you have done this, have technical debt stories. So every sprint we'll do one story that's a technical debt reduction story. Or probably I've seen more commonly, we'll have 5 regular sprints, and then the 6th sprint or whatever will be a technical debt reduction sprint. Has anybody done that?
Is that called refactoring?
Ooh.
I would not call that refactoring. I would call refactoring as very micro. I'm in the code. I'm working on this. I'm going to make this code a little bit better. I would call this sort of like redesign.
It's a very
Yeah.
abused term. It's
Yes.
poorly understood.
Yeah, I would.
Next question.
Oh, sorry. The only point I would have with this is I would get crystal clear. If my suggestion is get crystal clear about what we mean by refactoring and redesign, and define it in such a way that nobody needs permission from anybody to refactor. That's the key. I'm in the code. I'm refactoring. I'm going to make this code better because that's my job. Right? If I have to go say, hey, is it okay if we put this story in the backlog? That's like asking permission to do that. So that's no longer, to me, to distinguish those, I would call that redesign, because redesign, you need to get someone else to say, yeah, that should go in the backlog and do it. And then the advantage of that is that you don't need permission to refactor. Yeah, refactor is just part of your job. Nobody asks you permission to check in your code in the source code control system. Nobody asks you permission to type into the IDE. That's just part of your job, and that's how refactoring should be. So use the word in a way that you don't need permission to do it. That will be, because I find that term bleeds, and it causes confusion, and people say, no refactoring.
Get
Right?
the book,
So
get Martin Fowler's book.
Yeah.
That'll-
Was there another question? Yeah.
Let's say if you don't have automated tests, would you still recommend to have the team work on a technical that uses Windows, right?
No,
Because
I
every time
wouldn't.
you touch the code,
Yep.
you might impact other parts or other features.
Yep.
Yep.
So the question is, should you, if you don't have automated tests, should you refactor?
Or what is,
What is that? Yeah.
yeah, or what is an alternative? Let's say we don't have automated tests.
Yeah. So I would start to refactor and build automated tests as you go. So Working Effectively with Legacy Code is an awesome book that gives tips for that. And the good part is a lot of the new IDEs, especially with typed languages like C# or Java, will give you the ability to refactor code safely without tests. You can do a safe refactoring that are like, they're never perfect, but they can be like 99.99% sure that if I apply this refactoring, that it is not going to functionally change the behavior of the code. So there are safe, and I find most developers are very blissfully unaware that in their IDE, they have these powerful refactoring tools that they don't even know about. So there's lots of refactorings you can do safely without tests. But I prefer to have tests myself. Other people will, there's a guy named, oh, it doesn't matter, but I can't remember his name off. Arlo Belshi talks about safe refactorings. So if you Googled Arlo Belshi, he'll talk about refactoring without tests. So anyway, my favorite of these is the Boy Scout rule, which is simply just leave the code cleaner than what you got at it. And that has a wide variety of benefits. The main one is that the code that changes the most is the code that that you should refactor, because it's the most likely to attract new bugs as you write new code. So if you always leave code cleaner than you left it, then you're automatically improving the code that's probably the most subject to future problems, or is already future problems, or the problems might already be in that code. So the Boy Scout rule, and you shouldn't need permission to do that. Just have a rule in your team, leave the code cleaner, leave the campsite cleaner than you found it.
Just curious, in your experience, that like we're talking about peer programming or mob programming, I mean, you mentioned the pushback from the manager, but have you ever experienced pushback actually from the developers or the team itself? Because
Yes.
they don't feel comfortable interacting with other people. Like any suggestions, strategies towards that?
Don't force it on them.
Yeah. Experiment with it. I mean, it can be socially demanding for some people.
Right.
So I would experiment with it and have them try. I mean, it does maximize learning. So I think most people would find a way to do it a little bit, and then you can get some of the benefit. But
Yeah. We got 2 minutes. We can skip over some of this, I think. Wrap up. I was going to tie everything together to bring back some systems thinking and Deming. When he talks about how to improve an organization, he has something that's called the chain reaction, which starts with, unsurprisingly, let's focus on quality. So most of the time when I talk to teams about how can we get better, I talk to their leadership, Say, focus on quality, the rest will follow. Don't get hung up on all of the shiny baubles of the other things that will distract your attention away from this. Focus on improvement of quality. From here, it's a knock-on effect. We're going to have lower costs because we're not going to be worried about chasing down wild alleys and blind alleys and putting out fires. And that means we're going to be more productive. We're going to be spending time writing code that's useful, and we're going to expand our market because of it. People are going to want what we have. And that means we stay in business. This is really a very big problem. Because if your organization is spending the majority of its time, much like Declan's customers have alluded to, where they are spending an enormous amount of cash trying to maintain what they've got but not innovating, that's going to bring you down. And you're not going to stay in business. You're not going to provide more jobs. In fact, you're going to lay off people. And I already see that happening. It's the first lever that management will reach for when things get too expensive. So a major takeaway from this talk is that while we're suggesting things and strategies that you can do on your teams, and they are good because you do need to be technically competent, just changing how people type is not going to change the system. It needs to be a concerted effort from the top to the bottom. And you'll see that Declan and I have made this point several times throughout this presentation. It starts at the top. It's not something where it's good enough to say, go forth and be agile. It is, we are going to change fundamentally the way that we work so that we emphasize quality first. And we are going to work at achieving that. And we're going to align the organization to make that happen. So this is a quote here from Peter Schultes, contemporary of Deming's. Changing the system will change what people do. Changing what people do will not change the system. And this is a card game that's called Flux, if you're not familiar with it. It's a game which is a great metaphor for changing systems because it's all about changing the rules in the middle of the game. So you're changing the context of the system of the card game where you're trying to play hands and get rid of cards as quickly as possible, but you can introduce a change and suddenly the whole dynamic of the system shifts with it. So, shall we conclude? Wrapping up.
Yeah. So one thing I've really come to appreciate that technical debt is not a problem, it's a symptom. And specifically, it's a system, when we have increasing technical debt, that is an indicator that there's challenges in our system. And we can use what I hope it was obvious that we're introduced some sort of like general purpose causal loop diagrams to help you think about it. And what we really encourage you to do is to meet with your team or meet with your management and talk about like which factors are applicable to you in your context. Every diagram would look different. And try to map out that cause and effect and include technical debt in there and see how it connects to the rest of your system, because that will inform how you might want to deal with it. And I would be curious, after this talk I was curious, does this term technical health resonate with you now? Does this make sense in a way that perhaps technical debt might not? Because it's a richer view that I hope will resonate more strongly with leaders in our organizations, that we can have better conversations, because they just think, oh, you're just trying to shiny up that code, right? But here we can show, no, there's actually long-term system impact to us as an organization if we take care of this.
Yeah, so first answer is yes, it does resonate. But the other thing, and I thought you were very close to saying this, but to say something about it, technical debt is not necessarily bad. The analogy I use when talking with finance people is the difference between debt and deficit. Deficit can be a really powerful positive thing as long as you don't let it get out of control, in which case it's accumulating debt.
Yeah.
That may be.
So the point there was that deficit might be a better way to talk to financial people rather than debt.
Or just get them on a whole new vocabulary.
Just on that note, I just want to say one thing. I think it's really important to remember that when Ward Cunningham invented the term technical debt, he did it because he was working with finance folks, and he knew that if he drew that analogy to code, they would get it because it was their world, right? You could pick a different world. You could pick a different metaphor. I worked with an insurance company, and I used the metaphor of risk. What is the risk of us being like, cast it all in risk, because that's how insurance folks think. What would be the premiums we would have to pay to offset that risk? Or if you're talking like the firefighters, like what is
How do we
putting
stop the
out fires.
conflagration?
So if you can find a metaphor, like don't get wed. I think the term technical debt to me has somewhat got overplayed because I know people are now like, oh, go measure the code, and that would take 2 minutes to fix that, and we sum that up all over the code, multiply by our labor rate, and we have technical debt of $500,000.
No.
Like I think that's sort of like overly simplistic, right? But if you can find a metaphor that resonates with your leadership that's aligned to your business, you'll probably get their attention. And at the end, we'll put these slides up, but there are a few books there that are 3 technical books and 3 systems thinking books that we think are relevant to the material that we covered here today.
Yeah.
So with that, thank you very much for coming.
Thank you.